Alright, let's start this section 3.2, solving by substitution. In the last section, you're given a system of two equations and you're asked to solve graphically. That means to solve or find a solution of the system of two equations, you have to graph two lines. And remember, there are three cases: either both line intersects, or both line parallels, or they overlap to each other. Okay, same lines, they represent the same lines. So last time we solved for a system of two equations by graphing. So now, section 3.2, we learn to solve a system of two equations by substitution. That means you don't have to graph it or graph both equations. So that's the purpose why we learn this method called substitution method. Now, make sure you read the special case when solving a system of two linear equations in two variables. If a false equation is obtained such that 0 equals to 7, then the system has no solution. The system is inconsistent and the equations are independent. So if you're given a system of two equations and you solve for x and y, and it turns out you get a result 0 equals to 7, okay? Suppose given two equations x, y, you solve for it and you got a statement 0 equals 7, which is false. In that case, you would say that the system has no solution and it is inconsistent. Remember, inconsistent means no solution, and the equations are independent. That means they are not intersect each other's. They are different lines. Okay, that's independent. Now, the second special case is if a true equation is obtained, such as 0 equals to 0, then the system has an infinite number of solutions. The system is consistent and the equations are dependent. So, same scenarios. You're given two equations in terms of x and y, or two variables, and you solve, okay? But this time you get a true statement. For example, right here, 0 equal to 0, okay? This marker almost dead. Let me use this blue color now. You get a true statement, which is 0 equal to 0. This is true, right? 0 is always equal to 0. That means you will have an infinite number of solutions. And the system is consistent. Remember, consistent means the system has at least one or more solutions. And the equations are dependent. Dependent means the two equations are on the same lines, okay, or they represent the same lines, okay. So that's the special cases. Now I will start with example 2 on page 254. Find this example 2 on page 254. Okay? Solve the system two x plus y equal to 6, 3x plus 4y equal to 4, 2x plus y equal to 6, 3x plus 4y equal to 4. So, given, solve the system. If it's in a quiz or test, it is really up to you, because if I don't specify here, it is really up to you if you want to use the substitution methods, or you can use the graphing to find solution of this system. Now, because we learned in this section solving by substitution, so I will use the substitution method. Now, to use the substitution methods, let's solution here. Let's call the first equation right here equation 1. Right? So I give a notation here 1. Let's call this equation equation 2. So I give a notation 2 here. Okay? Alright, now substitution means you have to solve for a variable, meaning you have to solve for y equals something, and then substitute y equal to that something to the other equation. So there are two equations, right? You can choose, for example, pick the first equation, solve for y. Then you substitute that value of y in the first equation into y in the second equation. Okay, by doing that, you simplify or you eliminate the equation 2 from 2 variables to 1 variables only. Okay, because after you substitute y into the second equations, the y variable no longer exists in the second equation. All variables in the second equations now are in terms of x. Okay, now I know it's a little abstract, but I will show you what I meant here. So this I call it equation 1, this I call equation 2. Now I'm telling you solve for y equals something, right? Or sometimes solve for x equals something, depend on what you're given. Now for this case, look like equation 1 is already in terms of y right here, right? Y, just 1 times y, which is y. And we want to solve for y. You can solve for x too, but for this case, y is already in the form y. So I'm going to pick equation 1 and solve for y. And then I will substitute whatever y equal to into the y in the second equation. I pick the first equation because it's already y's here. Second equation is 3x for y. It's not x alone, or is y alone. Okay. So let's pick the first equation. 2x plus y equal to 6. Okay, and this is equation 1. And I'm going to solve for y. To solve for y, subtract 2x on both sides. Simplify 2x, subtract 2x, 0. Y plus 0. There's no y here, means 0y. Y plus 0 is y. There's no constant term here, means 0. So 6 plus 0 is 6. There's no x variable here on top, means 0x. So 0 subtracts 2x is negative 2x. Simplify, we have y equal to 6 minus 2x. Okay, so this is equation 1. I just convert this form, this equation in the form where both x, y on the left, to the form where only y on the left, everything else on the right hand side. Now, I'm going to substitute this y equal 6 minus 2x from equation 1 to equation 2. Alright, so equation 2 is 3x plus 4y equal to 4. And this is equation 2. So I substitute this y into this y in equation 2. Now, before I do that, look at this. Equation 2 has 2 variables, right? X and y. And pay attention after I substitute this y into this y here in equation 2. So pay attention to see the changes, okay, in terms of how many variables in the equation after substitution. So 3x plus 4. Substitute y right here into this y right here, which is 6 minus 2x equal to 4. Alright? Now, look at this equation now. How many variables? How many different types of variables? This is x. This is x. So the only types of variable now after the substitution is x. There's no longer y. That means you can solve for this equation. Okay? So another way of saying is that if you have two variables, in this case x and y, you need two equations. You need minimally two equations to solve a system of to solve equations with two variables. So for equations with two variables, you need minimally two equations with two variables. But in this case, there's only one variable now. It's only x, right? That means all you need is one equation. Then you can solve the variable. Okay? So let's solve for x here. To solve for x, you need to remove the parentheses. So I multiply the coefficient 4 to each term inside parentheses. 3x plus 4 times 6 is 24. Subtracts 4 times 2 is 8x equal to 4. Combine line terms, 3x and negative ax is negative 5x. This is a constant term state equal to 4 on the right hand side. Okay. Now to solve for x, we need to remove this constant term, so subtract 24 on both sides. Negative 5x plus 24, subtract 24 is 0. 4 subtract 24 is negative 20. You can solve for x by divide both sides by negative 5. Okay. Dividing negative 5, you get negative 5 divided by negative 5 is 1, right? Because negative 5 divided by negative 5 is positive 1. 1 times x. Negative divided by negative, positive, okay? So 20 divided by 5 is 4. So that means simplify 1 times x is x equal to 4. Okay. So you know that x is 4 now. Okay. If you know x equals 4, can you solve for y? Now, we know that x is equal to 4, okay? So which equation is that you're going to use? So we have two equations, 1 and 2. Now just remember, equation 1, we already found its equivalent form, which is y equals 6 minus 2x, okay? This is also equation 1, just written in a different form. So, since you have got the x equals 4, you can find y by substitute this x equals 4 into this x in equation 1. So let's substitute x 4 into the equation 1. Let me erase this part. So let me rewriting what we got so far. X equals 4. Okay. Now substitute x equals 4 into equation 1. So this equation 1. 6 minus 2x, right? This is from equation 1. Okay? So this is substitute 4 right here and here. You get y 6 minus 2 times 4. Simplify. 2 times 4 is 8. So 6 subtracts 8 is negative 2. So that means y is equal to negative 2. Okay? Now, when you see solve this system, it means what is the order pair x, y is the answer, okay? So what we got so far is x equals 4, y equals negative 2. So you can say the solution is, just write the order pair, because there's only one solution, which is the order pair. What is x? First coordinate is x, right? X is 4. Second coordinate is y. So what is y? Negative 2. So the answer is 4, negative 2, written in the order pair. This represents 1 point. And for this system, is actually, because if it has one solution, right, that means they intersect. If you grab it, it goes in this form, okay, intersects 1 point. That means it's consistent and independent, right? So this example,